This is an overview of what we're covering this semester and the syllabus and a few things that you need to know and need to think about. Um, from the context, from an educational standpoint, physics as a program here, since we don't have majors, we concentrate on different things than sort of the majors would. Um, so our physics program goals, right, are for you to explain how physics applies in the world around you, and for you to recognize where physics exists in your major. And this course is a great place to kind of see how physics is embodied in almost everything. Um, well, it actually is embodied in everything we do, all right, and all the processes around us. Um, Things we want you to be able to do when you come out of a physics course. All right, recognize the universal laws relevant to a system you're looking at. Think critically about and discuss how physical laws govern the behavior of a system. Apply those laws. That's kind of like solving problems, right? Applying mathematical and computational techniques to solve problems. Use experimental, computational, theoretical models, and evaluate the limitations of your solutions. All right. And so these are the sort of skills and the thought processes we want you to have. This semester, we're going to be doing it in the context of medical and biological physics. And so what is medical and biological physics? Well, this semester we've got a menu of 9 chapters. I'm going to tell you right now, we're going to cover chapters 1, 2, and 3. I've got them laid out. We're definitely doing those. But you get to pick which 3 of the remaining 6 we cover, because we don't have time to cover all 9. This text properly should be a 3-semester course. I try and do it in 2, and I do it in 2 by dropping some of the content out. Again, if you go back to my goals is to understand how physics works much more than understanding any particular piece of physics, um, and get a better feel for, oh, wait, there's something physical going on here. Let me understand that. So, what are the chapters we're going to cover? We're going to cover mechanics. We're going to cover exponential growth and decay. We're going to cover systems and many particles. But you have to rank order the rest. And you're going to look at them enough. I'm going to describe them in brief here, but you're going to look at them enough to have an idea of what you want them, which ones you want to cover the most. Right? I mean, for instance, if you put nerves at the top of your list and somebody else puts it second and somebody else puts it third, well, it's going to end up being one of the three, right? So the class is going to be um, picking from these last 6. Mechanics is how do you think about, how to think about modeling the body, forces on tendons and joints, how centrifuges work, cardiovascular system, viscosity, things like that. Things that you have, for the most part, concepts you have covered in your other physics classes, but you've never necessarily applied them here. Um, that's what mechanics is. Exponential growth and decay, that's about modeling exponential processes like viral outbreaks. We're going to look at log plots and how to do those in Excel and make fits in Excel. We're going to deal with variable rates, bacterial growth rates, processes with multiple decay path in the logistics equation, which is a great equation for basically how does a process grow exponentially but with a limited environment. The third chapter, System of Many Particles, is basically thermodynamics. It would be Chemistry 371 in at Delta State. But we're building towards the thermodynamics of biological systems and of cells and things like that. So we'll look at equilibrium conditions, the Boltzmann factor, the Nernst equation, Gibbs free energy, and the chemical potential. And while we're looking at these at the sort of standard level you do in chemistry, we going to be thinking about them more in the context of cells and parts of the human body. And one of the reasons we're definitely covering this chapter is that chapter 3 lays the foundation for several of the other chapters. So we can't really skip chapter 3 and do chapter 4. Um, so we're covering chapter 3 for that purpose. Chapter 4 transport and infinite medium, flux, fluence, solvent drag, diffusion, diffusion in cells. Um, Chapter 5, osmotic pressure in liquid and gases, volume transport through a membrane, artificial kidneys, countercurrent transport, volume and solute transport, all those kinds of things. That's what we're going to be covering in Chapter 5. Chapter 6, the nerves and how do they work? I mean, that's really what this whole chapter comes down to, is how do our nerves work? Charge distribution to cells, how do the electrolytes play a role in the cell in the transmission of signals along the cell. Um, Chapter 7, exterior potential and electrocardiograms. So this will begin looking at how our axons create these electric fields that we can actually measure. Chapter 8, biomagnetism, which is the flip side of electric fields. We're looking at magnetic fields and how our biological systems create magnetic fields, interact with magnetic materials. And then electricity and magnetism at the cellular level. And so, again, membrane channels, potential charges, effects of weakened of external external electrical and magnetic fields, right? These are the kinds of things in chapter 9. So you're going to have to kind of make your mind up, chapters 4, transport in infinite medium, 5, transport through neutral membranes, 6, nerves and muscles, 7, electrocardiograms, magnetocardiograms, um, electricity and magnetism at the cellular level, and how it has a lot to do with membranes. Um, and and then once you've kind of made your decision on which three of these you want, right? Then we're gonna I'll build out those pieces of the course. But for right now, mechanics, exponential growth and decay, systems of many particles, those we're definitely covering. Let's look a little bit at the syllabus. So from the syllabus, if you take a look at it, you're going to find that it because of the way I've laid out the syllabus, you have yet another task. So these are the weights I've given to the different activities you're going to do: reading quizzes, discussions, problems, literature review, midterm exam, final exam. But this adds up to only 70%. You actually have to help decide how the additional 30% gets divided up. That's on you. And so you're going to there's an assignment called assignment weights. You're going to go through that and you're going to give your preference on how you like for this to be by adding in your 30% where you want it. And I'm going to average what the whole class does to give a new set of weights, and I'll publish a revised syllabus once I have that. Um, from the syllabus again, we've got in every content module. So for chapter 1 module, chapter 2 module, we've got a reading quiz, we've got discussion, and we've got problems. All of those are going to be part of what you're going to be covering. Um, and the other thing that I haven't mentioned yet, there's a Discord server I've set up for this class. There's a little quiz or survey you have to fill out to give me the email address you want me to use to give you an invite to that Discord server. Also from the syllabus, there's a literature review you're going to be doing. This is going to be 10 papers, and we're going to do it in pieces throughout the semester. So it's not just I'm throwing you to the wind, hey, give me a paper at the end of the semester. No, we're going to have a discussion about it. We're going to look at your bibliography. You're going to have a draft of that. You're going to kind of write a little bit about how all that gets organized together after you've read it all. You're going to give a draft paper, and you're going to give your final paper. Um, and we've got 3 midterm exams. We've got 1 final exam. So those you'll have online, of course. They'll be in parts. Um, and the way I do these exams in parts, there's a timer for each piece. And and these will have a piece that you can work on together. And so I'm going to give you a discussion question you have to do on your own, multiple choice you have to do on your own, some simple problems you have to do on your own, but then a problem that you have to work together, right? And so the on working together on that problem, you guys are going to have to be organized around when you meet, how do you meet. That's one of the reasons we have Discord, but you're going to have that problem to work together on. At the final exam, um, just like with the midterms, there's going to be a problem or two that is a little bit more difficult that you will work together on. Attendance, this is an online course, so attendance is you actively participating in the course each week. Fortunately for you, there's an assignment due every week, so that's easy. Just keep up with the assignments and your attendance is on. Our loose schedule, our weekly schedule from the syllabus, right? Getting started mechanics, 2 weeks of mechanics. Your bibliography is due during that time. Your topic selection is due during that time. Exponential growth. Um, at the end of exponential growth, there's the first exam. During the first week of thermodynamics, you have to do your review organization. And then there's the fourth content module. We don't, and it just says fourth content module because I don't know what you're going to pick yet. And exam two, your draft paper is due after exam two with your fifth content module. Your sixth content module comes to exam three, then your final paper, and then your final exam. And so you'll see we're done with exams except for the final by 15th of November. And then this is when the final exams will be this semester. Hopefully that kind of gives you a good overview and will help you decide what you need to do. You will see announcements coming out from me on a regular basis reminding you about different activities that you need to be participating in and different things that are due. And announcement at the beginning of the week, each week, kind of saying, hey, this is what's up this week. So hopefully this will be a fun course and we'll all have a lot that we'll learn as we go along. I'll talk to you soon.